The coordination number and the geometry of complexes. Objective: to learn the geometrical structures of coordinate complexes. The ions of the transition metals, ones such as nickel, cobalt, and platinum, can form coordination complexes. The number of substituents or ligands bonded to the central metal ion will determine the ion's coordination number. This number affects the geometry of the complex. The coordination numbers 4 and 6 will form the most common complexes in the transition metals. If the complex has a coordination number of 4, its geometrical complex can be either tetrahedral or square planar. In a tetrahedral complex, a central atom is connected to 4 substituents. The ideal bond angles are about 109.5 degrees when the constituents are all the same. This can be seen with nickel carbonyl, also called tetracarbonyl nickel, NiCO4. Similarly, with copper-2 chloride, the copper-2 ions will have 4 chloride ions bonded to them. A coordination complex with a coordination number of 4 can also form a square planar complex, which is a complex having a central atom connected to 4 constituents in such a way that it forms the 4 corners of a square on a plane. This complex is found in metal ions such as nickel, palladium, and platinum. Consider cisplatin, an anti-cancer drug comprised of platinum, ammonium, and chlorine. In cisplatin, the central atom, platinum will be surrounded by the constituent atoms nitrogen and chlorine, which form the corners of a square on the same plane. If the coordinated complex ions have a coordination number of 6, the geometry will generally be octahedral. With this type of geometry, 4 of the substituents will be found on one plane, while the 5th and 6th will be found above and below that plane. In molybdenum hexacarbonol, MoCO6, 4 carbons will be on one plane and 2 carbons will be perpendicular to that plane, with all 6 surrounding the molybdenum. Summary: the transition metal ions form coordinate complexes. The coordination number will affect the geometry of a complex. The coordination numbers 4 and 6 will form the most common complexes in the transition metals. Complexes with a coordination number of 4 will exhibit tetrahedral or square planar geometry. Complexes with a coordination number of 6 generally exhibit octahedral geometry.